All right, so we're talking about 2.6 rational functions and asymptotes. So the definition of vertical and horizontal asymptotes is up here at the top. This little arrow right here means approaches. So the line of x equals a is a vertical asymptote of the graph when f of x, or your y value, approaches infinity, or f of x approaches negative infinity, as x approaches a, either from the right or from the left. The line y equals b is a horizontal asymptote of the graph of f when f of x approaches b, as x approaches infinity or x approaches negative infinity. And we'll learn more about that in a minute. All right, so if we have a rational function, we have some stuff on top and some stuff on the bottom, and there are no common factors, then we know that the graph of f has vertical asymptotes at the zeros of the denominator. So if I take the denominator, let's say the denominator is x minus 2, I would set that equal to 0, and I know that I have a vertical asymptote at 2. All right, the graph of f has at most one horizontal asymptote determined by comparing the degrees of the top and the bottom. So if the degree of the top is smaller than the degree of the bottom, then the graph of f has the line y equals 0. So let's say that the top is 2x minus 2, and the bottom is x squared minus 4. The degree up here would be 1, and the degree here would be 2 on the bottom. So when that happens, then I automatically know that my horizontal asymptote is y equals 0. Okay? If the degrees are equal, like what part B is saying, so let's say I have 2x minus 2, and on bottom I have x plus 4. So that's a degree of 1, that's a degree of 1. So then I look and I go, okay, well, I'm going to take the leading coefficient of the top, which would be this 2, and I'm going to divide that by the leading coefficient of this, which is 1. So I know that my horizontal asymptote would be y equals 2. If the degree on the top is bigger than the degree on the bottom, then you don't have one. So let's say that this was actually on top and this was on the bottom. They're flip-flopped, then I wouldn't have a horizontal asymptote anywhere. All right, so on number 1, we're going to find all of our asymptotes. So let's start with the vertical. So to find your vertical asymptotes, I'm just going to abbreviate that with vert. You're going to take the bottom, your denominator, and you're going to set that equal to 0. So I have 3x squared plus 1 equals 0. And I'm just going to solve for x. So subtract the 1. So 3x squared is equal to negative 1. And then I'm going to divide by 3. So I have x squared is equal to negative 1/3. But then if I square root this, which is what I would need to do, what's going to happen here? I'm going to get an I, okay? And when you get an I, that means that you don't actually cross the x-axis, right? Like, in other words, if I had like a quadratic function, all right, and I drew it like that, I would have 2 zeros, but they would both be imaginary because I never actually touched the x-axis. So if you're going to get an I, then that means you don't have a vertical asymptote. And if you actually think about this, is there ever a time when you would put a number in for x, you would square it, multiply it by 3, and add 1, and come up with a 0? Because even if this is 0, you still add 1. So you're never going to get a 0 there, correct? So if you kind of actually give it a little bit of thought, you could have figured that out to begin with. But if you don't, and you actually go through here and you realize, oh, I'm going to square root this negative right here, that's going to give me an I. I don't have any. So vertical asymptotes, we have none. So horizontal asymptotes, that's where we're going to compare degrees, all right? So I'm going to look at this, and the degree is always the biggest power that you have on your exponent. So up here I have a 1, and down here I have a 2. So the top is smaller than the bottom. So if you look at your three options here, when the top degree is smaller than the bottom, N represents the top, M represents the bottom. When the degree on top is smaller than the degree on bottom, then it is y equals 0. So I don't even have to do any calculations. So y equals 0. All right, so for number 2, let's talk vertical asymptotes first. So I'm going to take this up here, this bottom part, and I'm going to set that equal to 0. And then I'm going to solve for x. So I add 1. X squared is equal to 1. And then I'm going to square root. But I don't want to forget that I'm going to have a positive answer and a negative answer. So I actually get plus or minus. The square root of 1 is 1. So I have 2 vertical asymptotes. I have a vertical asymptote at 1, and I have a vertical asymptote at negative 1. All right, so then I do the horizontal, and that's where I'm going to compare degrees on top and bottom. So if you look at the top, your degree up here would be 2. If you look at the bottom, the degree down here is 2. And if you look at your options here, when the degrees are the same, you're going to take the leading coefficient from the top and divide it by the leading coefficient of the bottom. So if I look up here, let's pop down. The leading coefficient is that one that's in front of your biggest degreed term, right? So I've got a 2, and in front of this x I have a 1. So I'm going to say y equals 2 divided by 1, which is just 2. Now, although I want you to show the work, there are ways to look at this on a calculator, so grab that. All right, so this is the graph of number 2. So we said we had a vertical asymptote at positive 1 and negative 1. So that's straight up and down. So if you look right here, do you see how this is going? This is going up right here, right? And this is coming down and approaching that. That means that there's an asymptote right there at negative 1. You also have another one right here, right, at positive 1. And then you have a horizontal asymptote at 2. So if you look and see how this is flattening out right here, that's because there is a horizontal asymptote right there. Sometimes it's kind of hard to tell. Some people might say, well, I think that's at 1, but it's really not because it's flattened, right? Which means it's not ever going to cross that. It's going to stay above it and just get really, 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 really close. But it never stops getting close. It's kind of like, does a ball ever actually stop bouncing? So like if you have a ball, and let's say that every time it bounces, it's 3/4 of the way to stopping, do you ever actually stop if you're constantly cutting it by 3/4? No. Food for thought. All right, so on number 3, let's start with the vertical. So I'm going to take the bottom, and I'm going to set that equal to 0. So x squared minus 4 equals 0. So I add 4. So x squared equals 4. Then I'm going to take care of the square, so I square root, and don't forget you have 2 answers. So x is equal to plus or minus 2. So I have 2 vertical asymptotes. I have one that's going to go up and down at 2 and one that's going to go up and down at negative 2. And then horizontal, you're comparing degrees. So if you look up here, the degree of the top is 2. The degree of the bottom is 2. So when they are the same, you're going to take the numbers in front of those and divide them. So I've got 3, and then on bottom I have 1. So 3 divided by 1, that gives me 3. And remember, you're not going to have more than one horizontal asymptote. You only have one. But you can have more than one vertical asymptote. And again, you could graph that and take a look at it. All right, so we're finding asymptotes and holes. Okay? So here's the thing. You get a hole when you do have matching factors on top and bottom. So really your first goal when you work these is you're going to factor anything you can factor. Okay? So number 1 on your list is to factor it. So I'm going to start with the top. I've got a trinomial. I'm going to factor that. So I've got a minus at the back. That means I have a plus and a minus. And then to get my x squared, I know I have to have x times x. And then I'm looking for two numbers that are going to multiply to make the 2 and subtract to make 1. Well, there's only one thing that multiplies to make 2. That would be 2 and 1, right? But I want the middle to be a positive 1x. So that means I have to put the 2 with the positive and the 1 back here. Because 2 plus a negative 1 would give me a positive 1. Okay? All right, so I've got that factored. Now I'm going to factor the bottom. Again, we have that minus at the back, so I'm going to have 1 plus and 1 minus. And I've got an x squared, so x and x. And I need two numbers that are going to multiply to make 6 and subtract to make 1. So you have 6 and 1, but that subtracts to make 5. 3 times 2, that will subtract to make 1, right? But I want this middle to be a negative x, so I'm going to have to put the 3 with the negative and the 2 with the positive. So this is what happens. Now that I've got this, I see that on top I have an x plus 2, and on bottom I have an x plus 2. So those are going to cancel, and that's going to leave me with a hole in my graph. All right? So I'm going to take that factor that I canceled, and I'm going to set it equal to 0. And then I'm going to solve for x. So I subtract 2. So x equals negative 2. So when x is negative 2, I'm going to have a hole in my graph. Okay? All right, now let's talk about what's left over. So left over on top, I have the x minus 1, right? Left over on bottom, I have x minus 3 because I canceled that factor, right? Any factor that cancels gives me a hole every time. All right, so now I'm going to talk about my horizontal asymptotes and my vertical asymptotes. So to get the vertical asymptote, I'm going to take that bottom that's left over, right? And I'm going to set it equal to 0. Now, is it really necessary for us to do that? Like, I feel like at this point you guys probably know that to get a 0 on bottom, x has to be 3, right? So I have a vertical asymptote at x equals 3 because of this bottom right here. Then I'm going to talk about my horizontal asymptotes. So that's where I compare degrees. So if I look on top, this x has a power of 1. On bottom, this x has a power of 1. So when the degrees are the same, I take the numbers in front and divide them. So what's 1 divided by 1? 1. So y equals 1. Now, I will tell you this. Let's graph this and take a look at it. All right, so if you look at the graph of this, okay, you've got your vertical asymptote at 3, which is right here, right? I can't hit that because I'm blind. Okay? And then you have your horizontal asymptote at 1. Okay? But if you look, do you see any holes on your graph? There are no holes. Okay? The graphing calculator will not graph holes. All right? But, let's see. It was when x was negative 2, correct? So here's what would happen. If I graphed this on paper, I would go to when x is -2, and then I would go to where my graph was at that point. And I would erase that spot right there, and I would put a hole right there on that spot. Okay? Because if you actually go to your table, oh, I might actually have to. If you actually go to your table and you plug in -2, see how you get an error? Okay? That's because there's no y value there, because you can't have -2 as an answer. Okay? All right, so on number 5, first you're going to look and say, okay, is there anything that I can factor? So the top is just a number. I can't do anything with that. But the bottom, I do have a common factor. 28 and 36 will both divide by 4. So I'm going to factor that out. 28r divided by 4 is 7r. And 36 divided by 4 is 9. So I need to do that just to check to see if I have holes, right? Which, do I have a common factor between the top and the bottom that has like an x in it? No. Like I could take the 36 and the 4 and divide those, right? But that's not really going to help me, okay? So I don't have any factors with a variable that would cancel. So as far as holes go, I don't have any. So I'm just going to say none. So now we'll talk about the vertical asymptotes. I'm going to take my factors on the bottom and set them equal to 0. Now here's the thing. I can't set 4 equal to 0, right? It's just factors that have an x value you can set equal to 0. I can't do 4 equals 0. That doesn't even make sense. So I would just do the 7r plus 9 and set that equal to 0. And then solve. So subtract the 9. So 7r is equal to -9. And then divide by 7. So I have a vertical asymptote at -9/7, which would be 1 2/7, so a little bit past -1. Okay? And then for my horizontal asymptotes, I'm comparing degrees, right? So when there is no variable, that degree would be 0. Okay? And that's because, let's say that I had a variable there. It would have to have a power of 0 because x to the 0 power would be 1, and 36 times 1 is 36. So I have a 0 degree on top and 1 on bottom. So when the top is smaller than the bottom, what does that mean? It's on that very second page. Yeah, when the top is smaller than the bottom, then it is y equals 0. Oh, went too far. So y equals 0.